Hello everyone and welcome to another video from Brussels Developer User Group. This is video number 19 and today we are going to talk about univariate analysis using histograms, KDE plots and root plots. So to save some time, I installed ahead the Seaborn library. You can see this line of code pip install -u Seaborn. That's the library we are going to use on this video to plot the histograms. Then we need to import some of the libraries that you already are used to use. As we saw in the previous videos, we are going to use pandas, numpy, seedborn, and matplotlib. Then we are going to load our dataset. This dataset we saw it in the past, and it's basically data about hate of people, and that's basically it. Then we are going to use Seaborn to draw a plot based on the size. So we have here the plt.figure, just the standard size of the plot, and then we are going to use sns.thisplot with the height column, and then plt.show will show the histogram with a curve. That's the kernel density estimation curve. What about if we don't want the kernel density estimation curve, the KDE? So we put KDE to false, okay? And then we have it. What about if we want to change this to plot the data on the vertical axis? So we use KD equals false and vertical equals true, and there we have it. What about if we want to plot each data point as a stick? So we put rook equals true, and here we have the data. It's this one, and there you go. So we have this is the sticks for each data point. So between this section, you can see there are 1, 2, 3, 4, 5, 6 data points, and that means that it's evenly distributed. What about if we want to plot only the KDE and the rook plot? So we use rook equals true, KDE equals true, and histogram equals false. And you can see it here. We can also specify the bin numbers. The bin numbers are basically the size of the distribution of each bin, if that makes sense to you. So here we are using 40. Rooks equals true, KD equals false, bins equal 40. What about if you use 5? Let's check how it works. You see, the distribution is split into 5, which means that people between 175 and 185 represents the most bin frequency in this chart. Okay. What about if we want to plot only the rook plot? So we use height 0.5. We use the rook plot function with the same height data. This, what we can conclude from this plot is that data is evenly distributed across the entire data range. What about if we want to plot the kernel density estimation? So we use it with the KDE plot, sns.kde plot. We can set also some colors here. The height data and shade equals true, so you can see the shade or the background. We can also change the color of this, so we can use color equals to G, and you see it's green now. And finally, what about if we want to plot the KDE with different bandwidth values? So we see it here. So that's the bandwidth value of 0.1. So you can see a lot of data points here. And that's basically the last plot of this video. I hope you like this video, you find it informative, you learn a little bit. We have two other videos explaining plots. So that will make 21 videos for this series. So stay tuned, see you in the next one.